Internet of Things (IoT) describes the network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. Here's the history of IoT.
1970. The actual idea of connected devices was proposed. 1990. John Romke created a toaster which could be turned on/off over the Internet. 1995. Siemens introduced the first cellular module built for M2M, machine-to-machine. 1999. The term Internet of Things was used by Kevin Ashton during his work at P&G, which became widely accepted. 2004. The term was mentioned in famous publications like The Guardian, Boston Globe, and Scientific American. 2005. UN's International Telecommunications Union (ITU) published its first report on this topic. 2008. The Internet of Things was born. 2011. Gartner, the market research company, include the Internet of Things technology in their research. Next, we will go to see how the IoT works.
The entire lock process starts with the devices themselves, like smartphones, smartwatches, electronic appliances like TV, washing machine, which helps you to communicate with the lock platform.
Next is IoT application.
IoT solutions are widely used in numerous companies across industries. Some most common IoT applications are the following.
Smart thermostats. It helps you to save resource and heating bills by knowing your usage patterns.
Next is connected cars. IoT helps automobile companies handle billing, parking, insurance, and other related stuff automatically.
Third, activity trackers. It helps you capture heart rate pattern, heart rate pattern, calorie expenditure, activity, and skin temperature on your wrist.
And then, smart outlets. Remotely turn any device on or off. It also allows you to track a device's energy level and get custom notifications directly into your smartphone.
The next is parking sensors. IoT technology helps users to identify the real-time availability of parking spaces on their phone.
Then, we have Connect Health. The concept of a connected healthcare system facilitates real-time health monitoring and patient care. It helps in improve medical decision-making based on patient data.
Then, the next is Smart City. Smart City offers all types of use cases, which include traffic management to water distribution, waste management, and other.
Next is Smart Home. Smart Home encapsulates the connectivity inside your homes. It includes smoke detectors, home appliances, light bulbs, windows, door locks, and other.
Last is the Smart Supply Chain. It helps you in real-time tracking of goods while they are on the road, or getting suppliers to exchange inventory information.
Now, let's discuss the challenges of Internet of Things IoT. At present, IoT is faced with many challenges, such as
insufficient testing and updating, concern regarding data security and privacy,
software complexity, data volumes and interpretation, integration with AI and automation. Devices require a constant power supply, which is difficult, interaction and short-range communication. Here's the key benefits of IoT technology. Technical optimization.
IoT technology helps a lot in improving technologies and making them better.
Example, with IoT, a manufacturer is able to collect data from various car sensors. The manufacturer analyzes them to improve its design and make them more efficient.
Improve data collection.
Traditional data collection has its limitations, and it's designed for passive use. IoT facilitates immediate action on data.
Reduced waste.
IoT offers real-time information leading to effective decision-making and management of resources.
For example, if a manufacturer finds an issue in multiple car engines, he can track the manufacturing plan of those engines and solves this issue with the manufacturing belt. Improved customer engagement.
IoT allows you to improve customer experience by detecting problems and improving the process.
Now, let's see some of the disadvantages of IoT in this Internet of Things.
Security. IoT technology creates an ecosystem of connected devices. However, during this process, the system may offer little authentication control despite sufficient security measures. Privacy. The use of IoT exposes a substantial amount of personal data in extreme detail without the user's active participation. This creates lots of privacy issues.
Flexibility. There is a huge concern regarding the flexibility of an IoT system. It is mainly regarding integrating with another system, as there are many diverse systems involved in the process.
Complexity. The design of the IoT system is also quite complicated. Moreover, its deployment and maintenance also not very easy.
Compliance. IoT has its own set of rules and regulations. However, because of its complexity, the task of compliance is quite challenging.
We will now learn about best practices for IoT.
Design products for reliability and security.
Use strong authentication and security protocols.
Disable non-essential services.
Ensure internet managed and IoT management hubs and services are secured.
Energy-efficient algorithms should be designed for the system to be active longer.
Internet connectivity.
All IoT devices require a mechanism to send or receive data. There are numerous options available for connecting devices to the internet, including wired and wireless options, Bluetooth, cellular networks, and many more. The option you choose depends on various factors such as
scale and size of the network where the application will run, amount of data that needs to be processed, and transferred physical location of the device.
Internet connectivity options for lot devices. Example of simulation project. Ethernet module. LED. Arduino. Temperature sensor. Consumer. Serial communication port. The purpose of this is to make a web browser. The question is, what is web browser, and how web browser works?
Web server is a place which stores, processes, and delivers web pages to web clients. Web client is nothing but a web browser on our laptops and smartphones. The communication between client and server takes place using a special protocol called Hypertext Transfer Protocol. In this project, we are going to use the latter option to control an LED over the internet by interfacing Arduino with INC28J60 Ethernet module. The Ethernet module is used to establish communication between the computer and Arduino in a LAN or wired network. This article is written assuming that the reader has an understanding of basic computer networking, which includes having knowledge of connecting computers to hub or router with our J45 cables, IP and MAC addresses, etc.
We are using the ENC28160 Ethernet module. It is a single-chip full-featured Internet-enabled module to establish an Internet connection. It also supports hardwired TCP, IP protocols like TCP, PPPoE, Ethernet, UDP, ICMP, IPv4, etc. It supports ADSL connections and up to 4 simultaneous socket connections. The Ethernet module also uses the Arduino SMA library to write sketches that connect to the internet using this module. It fits all versions of Arduino like Uno, Nano, Mega 1280, Mega 2560, and others. The working and functionality of the ENC28J60 Ethernet module are very similar to that of an Arduino. Ethernet Shield, meaning you can do everything you want with an Arduino Ethernet Shield. As an advantage, it comes at half the price of a Shield. There is great information and examples of this module on the network, as well as different libraries. For this tutorial we will use one of the most used libraries, the EtherCard library.
Connecting Arduino to PC or router Ethernet port. To connect the two PC and Arduino together, we need a suitable cable Cat 6 crossover cable if the PC's Ethernet port doesn't have auto direction sensing. In case your PC supports auto direct sensing, just connect a regular cable that comes with the router.
That's all. I hope you learned something.